and George Manias, assistant professor at CHATS, both from the Netherlands. So, and they will talk about intelligent agents in cyber-physical ecosystems. So the stage is yours.
Thank you. Yes. Is it on? Yes, it is on. Okay, we thought to switch things a little bit up and to connect George's presentation to something very concrete. It's a vigilance project, it's an EU project. So we do a little bit of storytelling also today, just not to just make it all technical, but a little bit more around it. So my name is Sandra, I'm the CEO of Devisor, and within the Vigilance project, Devisor is acting as the technical management. So we do coordinate the overall technical integration, and we ensure that the different research components are combined together in a platform. And of course, together with me is George Manias. He will introduce himself a little bit more later. And today I would like firstly to explain why we start the Vigilance project, what problems that we are trying to solve, and why we believe that concepts like data mesh, agentic AI, and zero trust architecture belong together. Because the challenge is actually much larger than cybersecurity alone. Okay, let me briefly walk you through the project. Skip that. Vigilance is a collaborative platform with 18 partners from 8 countries, and but more importantly, it represents a shift in how we think about cybersecurity. For many years, cybersecurity has largely been very reactive. We detect a problem, we research what happened, and then we respond afterwards. But that approach is not sufficient enough anymore, because there are the environments that we are working in are increasingly difficult. They are distributed, they are interconnected, and they are continuously changing. And also, modern infrastructures, they produce a massive amount of events and a massive amount of data and telemetry. So human agents alone can't react to that in real time only. So what we do, so we investigate how AI agents can support operational systems, and not only as an isolated assistant, but as a collaborative, let's call it specialist, operating in these environments. And when we look at the ecosystems that we are working with as pilots, you can see that they are vary from logistics and mobility to telecommunication, industry, banking, and finance, and they look very different from first perspective. But when you look at the architectural perspective, you can see that they are very much alike, because they all consist of multi-independent organizations. They all exchange data continuously. They all combine IT, IoT, AI-driven services, and most importantly, they all have to collaborate within the same system and without giving up control of their own data and their own infrastructures. So although they differ from operational perspective, the architectural questions are remarkably similar. How do organizations collaborate without centralizing everything? How do we continuously verify trust? How do we cooperate safely with autonomous AI agents? And how do we remain a human oversight in all of this? So these questions ultimately led us to combining three complementary paradigms. Data mesh for federated ownership, agentic AI for distributed intelligence, and zero trust for continuous verification. And this is exactly where the rest of today's presentation will take us.
Thank you, Sandra, for this introduction, and thank you very much to everyone, and especially to the organizers of the Summer SOC for the kind invitation to be here. My name is George Manias. I am assistant professor in the Erasmus Academy of Data Science, located in Den Bosch in Netherlands, and also research associate in the University of Piraeus in Greece. So following the introduction from Sandra, where she gave a little bit of the overview of the context on which we will discuss today, but also Vigilance unfolds its objectives and activities. The three main pillars that Sandra just mentioned with regards to zero trust knowledge, data mesh, and agentic AI, and how everything comes together. This comes together, let's say, in a very high level operational stack with the main pillars that you can see here. So at the end of the overall discussions, this is kind of the pillars that we will follow in order to break them down and understand how these three main aspects and topics that we discussed are converged and collaborate together in order to provide digital resilience, sovereignty in the critical infrastructures that act also as pilots, and how we can operationalize and go beyond just architectural aspects. So as you can see, the main pillars is of course to enforce and improve the overall governance and compliance, of course through the utilization of agents and the overall inter-exchange and interconnection between humans and agents to agents, and etc. To operationalize a little bit the overall cyber intelligence that is needed in order to improve the sovereignty of the critical infrastructures. And of course, all this cannot be done without concrete and very efficient orchestration and response and recovery, but also to have in mind that we live in a federated environment where data cannot be centralized, and we have to apply specific policies and governance aspects in order to ensure that everything will stay in premises, but also to be connected and combined in the overall improvement of the intelligence layer. So why now? Why this question? Why we are discussing about this kind of projects? Sandra just mentioned that the cybersecurity is a emerging and rapidly evolving domain where we need not only to be proactive, but also to move on reactive actions in real time, monitoring in real-time recovery and response in our systems in order to protect them from cyber-physical attacks. But also, in order to do that, we have to understand that we live in an era, as also Simon mentioned before in his presentation, where more and more agents and autonomous systems are incorporated into the development of the data, the collection of the data, the standardization, the harmonization of the data, but also on the analysis and finally the leveraging the potential of this data. We hear more and more that all the enterprises, businesses, critical infrastructures, they want to fully leverage the potential of agents, but they neglect to say things about data, how we can extract the actual power and potential of the data in order to be leveraged by the agents. Either if we talk about quality of the data, either we talk about governance and compliance of the data, and etc. So agents cannot live and cannot operate fully efficiently without taking into consideration the aspects of data. So on one aspect, the cyber-physical ecosystems definitely are becoming distributed and autonomous. Okay, we need to to ensure the resilience and sovereignty, especially of the critical infrastructures. And also, we have to acknowledge that AI and agents are becoming more and more not only supportive tools, rather than actual decision makers. They actually being used and utilized in the overall decision-making approach, because we all know that they have this intelligent power, the reasoning, the planning, things and several skills that make them very powerful enough in order also to proceed with actual decision making and not going beyond just passive assistance. So the critical things that we have to bear in our minds is that definitely the cyber-physical ecosystems need federated, trustworthy intelligence, and we need also to bridge classical theory, because some of the things that we will discuss, we already discussed, come prior to the decades, but of course we need to advance and link them also with modern technologies and current implementations and developments. And of course this follows also the logic of the evolution of the software systems, what we have seen so far. Okay, so we have to move from deterministic to more probabilistic infrastructures and logic and mechanism, and we all know that we have moved from monolithic and service-oriented architectures to more autonomous multi-agentic ecosystems. But of course, this comes also with specific characteristics with regards to the autonomous operation, with regards to the reasoning, the planning, and other aspects that we have to take into consideration and advance in contrary to the traditional software verification. So, what we have nowadays, and also something that Simon mentioned previously in his presentation, we have a big converge of several different things. Big converge of skills, of governance, of compliance, of terms of use, of regulations, of the actual meaning of the data. So we move from traditional approaches to more improved and agentic data layers, where we have autonomous operation, manual construction of YAMLs, as was showcased before, in order the data to be actual, valuable for the agents, and be prepared for also for real-time signals, for real-time processing, enforce them with zero knowledge proofs, with policy-oriented aspects, governance, in order to move to more efficient gains and of course reduce the downtime of especially of the critical infrastructures. So we have to take into consideration domain-oriented ownership, self-serve infrastructure, federated governance that is encapsulated especially through the zero trust policies and enforcement mechanisms, something that we will see later how this is encapsulated into the overall architecture and functionality of the vigilance project. And of course, we have to acknowledge that we are talking about data as product and agent as product. By leveraging model cards, by leveraging the overall construction of the data products, we are able to offer them via any protocol, via any communication protocol, in order to be callable and fully functional and serve as accountable assets via the creation of evidence, auditing, and logging, and etc. So we are moving to more high levels of automation with regards to Gadrant, and of course to serve a federated approach with regards to how we can exchange data intelligence as products in the overall life cycle. But of course we have to take into consideration also that we are talking about multi-agentic systems. Multi-agentic systems that are let's say architectures where powerful multiple AI agents work together in order to solve complex problems. And of course we have to identify that once we speak about several different tasks, we talk about also agents that become experts into a specific domain or into a specific task. So they play a crucial role in the overall pipeline of the multi-agentic systems, and each one of them owns, of course, its own reasoning and planning strategy. And a specific example that you can see here in this slide is the SciSci GPT, a powerful multi-agentic system that was introduced by the authors in this paper, where it seeks to advance the human-AI collaboration in the science of science. So you can see here that we have one agent that a little bit governs the overall functionality of the overall pipeline. It proceeds with task the composition, the assignment of the different tasks into the experts, the other agent experts, and manages the overall orchestration and coordination of the responses and the overall functionality of the different agents. We have an hierarchical approach, as you can see here, architecture, in order to govern the overall functionality of the system. And of course, we have not only agent-to-agent interaction, but also agent-to-tool or agent-to-user interaction in order to facilitate the overall communication and the exchange of data flow and information between the different agents and steps. Of course, all this, in order to be fully functional, they use meta prompting and metadata that are available either for the agents to communicate between them or from the agents in order to connect with the different tools and sources in order to capture the needed information. So in a nutshell, this is a multi-agentic system, and also nowadays LLMs become the brain of the agent, thanks to the power, the potential. Also, we have seen also from Simon's presentation how LLMs are the central critical vital point in order to create manually YAMLs in order to operate specific tasks. So nowadays, because LLM has all this power in order to act as a specific persona with specific instructions, take into consideration the role, the domain, the context, and also through the power with regards to overall planning, and to proceed with specific actions, to collaborate and communicate with tools, with users, also to use short or long-term memory in order to retrieve the answers. So all this make them very powerful in order to be the central point that acts, plans, and overall generates the responses on the tasks that we need. So this is the critical point, and of course we have not to neglect that the agentic orchestration is more or less follows also what we have used also in the microservice orchestration. So they can use both centralized and decentralized choreography models, but of course another approach that we have seen also in the previous paper that we discussed is the hierarchical orchestration, where we have the breakdown of the tasks into different levels of agents and experts. So for example, we have the high-level agent that is reliable for the planning, the task, the composition, managing the overall processes and how the different tasks will be allocated to the different agents. We have the mid-level that they can refine, implement plans and delegate the lower tasks to the final workers that you can see in this hierarchy and final level. And last but not least, of course, we have to acknowledge that there are different communication protocols, either for the communication between agents to agents. Here you can see some indicative examples of standards and communication protocols that standardize the overall communication between the agents. And also we have the model context protocol with regards to how the agents can also interact with external systems and tools in order to fetch the knowledge and the data and the resources that we need in order to proceed with the actual actions of them. So all this come into the theoretical, just in order to all of us to create a common understanding and put all of us in the context of the multi-agentic systems, but how this is operationalized into the vigilance. How the aspects that also Sandra introduced before to you, zero trust, data mesh and agentic AI come together in order to be used in 4 different pilots and critical infrastructures. Of course, we integrate cybersecurity innovations with regards to cyber zero trust architecture, with regards to CTI, threat and incident hunting, adaptive threat exposure management, adversarial red teaming and AI powered pen testing. So these are functionalities that are incorporated, let's say, and are allocated to specific agents in order to help the security teams to proceed with more improved and fast recovery and response also in real-time threats. Of course, all these are combined with agentic AI systems and security innovations and multi-agentic architectures, and also we use blockchain, federated learning, and quantum security and cryptographic mechanisms in order to empower the overall functionality of them. And the validation and upscaling comes together in 4 multi-party ecosystems that you have seen previously with regards to logistics, the Port of Rotterdam, with regards to finance, bank, CaixaBank in Spain, telecommunication, OTE, member of T-Mobile group in Greece, and also Industry 4, Siemens, where are the pilots in the system. So, if we want to break down the overall functionality and how all these are integrated and come together, we have to follow also a reference model, an architectural reference model. And here I present to you how vigilance is aligned with the era, the industry, the industrial reference model in Industry 4, where we operate all the functionalities into 4 main viewpoints, because we have to break down the overall functionality based on the business value and impact that we seek to bring into the multi-party ecosystems. Of course, to understand how humans interact with AI, how we manage to provide human in the loop, on the loop, or human in command. These are the 3 types of human oversight that we will discuss together, and we have incorporated into the system to understand what are the user journeys, what are the needs and the requirements of the users that interact with the system. And after that, we move to the lower levels of the architecture, the more technical oriented ones, which has to do with regards to the functional viewpoint, what are the data flows, what are the evidence flow, how each agent interacts together in order to fuse evidence, in order to fuse information, what are the blueprints of the communication and that are created by the agents in order to proceed with the next step and next time functions. And finally, we have the implementation viewpoint, where everything is federated, where we follow also the 3-tier deployment in order to not only create the technology stack, the protocols, but also to proceed with the actual deployments in the premises of the pilots. And as we speak about functional domains, we have to also take into consideration not only the cross-cutting functions in the different domains that govern and ensure the compliance of the overall architecture with aspects like zero trust, like agentic AI mesh, communication protocols, auditability, monitoring, sovereignty, but also we have to understand that we need to develop systems that enforce and improve the trustworthiness and the overall reliability and sovereignty of the overall system. That's why you can see here that these 6 characteristics come on top of the overall functioning and integration of the different domains. And here you can see that we have also starting from top to bottom. We have the business domain, the actual operations that are incorporated into the functionality of the agents, the information domain that takes into consideration also the data mesh, the data layer that we incorporated into the overall functionality of the project, and after that moving to the control, the application, and the lower levels of the architecture. And this is how everything comes together following the three-tier system architecture of as it is introduced by the ERA reference model. So here you can see that we are talking about federated orchestration, federated approach that we follow in order the platform to be also operationalized into the edge tier, meaning into the specific premises of the different pilots. Then we have the platform and the enterprise tier that govern the overall functionality of the different components that you can see here. And also here you can also see especially how the information domain, the application domain, that means these are the two components that are closer to the end users. These are the user interfaces that we offer also for utilization, but also the overall backbone of the system, which is the operations domain and the agentic AI mesh functionality. And all this, of course, come together with specific governance and compliance and specific functionalities in order to ensure that we have a concrete strategy with regards to authentication of the users, the authorization, how the evidence comes to is fused from one step to another, and all these things, these tiers, are also governed by this vertical spine that you can see here in order to ensure zero trust across the whole exchange of data and across the whole life cycle of the data and evidence. So we have specific policy decision mechanisms that identify which are the critical points that we need to take decisions, that we need maybe to incorporate human in the loop, that we need maybe to escalate things into higher level of user trust or higher level of users. And also quantum technology is also here in order to leverage also the advancements of quantum key distribution, of quantum cryptography, in order to ensure that we have also zero knowledge proofs with regards to the exchange and the creation of evidence across all the different components of the architecture. And here I would like to zoom in into some specific parts of the architecture. The first part that I would like to zoom in and discuss with you is the federated data meshing practice, which is thanks to the utilization of the digital sovereignty assessment toolkit that applies the same 5 checks in a federated manner across every party of the ecosystem. So this toolkit encapsulates the identity management, the data protection and governance, compliance and auditing, monitoring of incidents and response, and threats and vulnerability assessment, thanks to leveraging the power of agents. So for each one of these steps and tasks, we have dedicated agents in order to function, in order to operationalize these specific tasks. And all this converges together, come together in order to provide the sovereignty of the activity that we need to address at this specific time, taking into consideration all these dimensions and all these perspectives. So this toolkit operationalized in a holistic manner, taking into consideration all these different dimensions and information that is derived into the system by the functionality of these 5 different layers. So each party, let's consider that each pilot, each party is a domain node with its own UI, with its own CM applications, intelligence, data, cyber, physical stack, and etc. So what this toolkit does the policies that manage the overall response and recovery of the system, the socio-technical security and regulations, the compliance issues that need to be taken into consideration in order to ensure that we have concrete and improved policy and enforcement in the response of the system. All these are coming together and are enforced as shared and federated computational governance that moves from party to party and from pilot to pilot in order to have a concrete intelligence layer that is exposed and is being communicated from one pilot to another. The other aspect that I would like to discuss with you and zoom in is the vertical spine that you saw in the architecture previously, which has to do with regards to the zero trust and identity insurance. So what we have here, we have four main mechanisms, four main components. Of course, the overall mandates, the regulations that govern and introduce the zero trust architecture across all the different layers, but also we have the policy decision and enforcement mechanism that provides continuous verification of every agent interaction and how all the knowledge and all the evidence is fused from the pipelines, but also thanks to the utilization of quantum-oriented approaches, we provide zero knowledge proofs for both the agents and the devices, and also we have PQC and quantum key distribution in order to ensure that the data and the information is transported via quantum key functionality and encryption mechanism. And how this comes together, here you can see how we can break down this into 5 specific steps. How a single agent request is verified. At first, the agent requests the action. After that, we have the identity that is proven via zero knowledge proofs. The policy and the compliance and the regulations are also checked. And finally, we have the allowance or denial thanks to the PQC secure channel before reaching the final end where the decision, the rationale, the evidence is written into the agent in order after that to proceed with the actions that are needed in order to provide evidence. So of course, all this pipeline means that nothing is trusted, not the information, not the data, not the knowledge, not even the agent, so everything needs to be proved before fused into the system. And the third and final aspect that I would like to discuss with you right now is also where the humans stand in this overall environment and in this architecture. Because we have not to neglect that also human oversight needs to be incorporated into the system. Because we cannot fully allow the autonomous reaction of the agents. All needs to be governed also and oversight a little bit also by the humans, but of course with a bit of balance in order not to overwhelm the critical policy points and not to increase the burden in the overall functionality of the agents. So we have to understand that all these things, humans is not out of the loop, and we need to control how we can connect people, agents, processes, technology, data and governance. In that aspect, we have 3 oversight models. We have human in the loop, on the loop, or human in command. Okay, so all these come with their own advantages and disadvantages, and we need to understand in each specific point of the pipeline and the information flow in which specific policy point or aspect we need to incorporate specific one of these models. And of course we need to understand that all these are not mutually exclusive, rather than in a high-risk AI system than the cybersecurity or in the healthcare domain, maybe we need to combine these three different models in the different points of the architecture and in the different points of the pipeline. So, for example, human in the loop maybe is needed at decision points or in points where we need to escalate the result of the agent or the action that is needed to be taken. Human on the loop maybe is needed during the runtime monitoring on the final recommendations, how the recommendations will be translated into decisions and actions in later stages, and of course human in command maybe is needed at governance level. Why this is needed? Because we need to have in mind that with regards to the principles that govern the systems and the design and the operationalization of the systems and the architecture, we have a missing link. So on one side, on the left side, we speak more and more, especially in Europe, where we are very great on regulations. We speak about protection of human values, fundamental human rights, about how we can create a responsible AI that is fair, unbiased, discrimination-free, that also fosters transparency and accountability. On the other side, we have the software architectures, we have the multi-agentic systems, that all of them come together with concrete layers, as we have discussed previously, and you can see also in the right, where we have the combination of data mesh layer, the explainability layer, and context orientation layer, and etc. So, what is missing here, in order to bridge this gap, and the efficient integration between data mesh, data products, agentic mesh, and overall operationalization and utilization of the system, human oversight is missing. So we need to understand what are the architectural decisions, what are the principles that enforce, measure, and translate these principles into actual developments and pipelines in the overall system. So moving from the single question, who approves the AI decision, we have to move to break down this question and ensure that we are able and capable enough in the overall systems that we design, that we have concrete answers in all these questions, in order to capture the full potential in a secure and trusted manner of the multi-agentic systems. And also, last but not least, I have with you one slide that we can discuss also later in the questions, of how the three pillars that Sandra introduced before and we discussed come together in the context of an indicative scenario, where we need to proceed with real-time anomaly detection and triage, where we have an attack in a drone in the port of Rotterdam. So the data mesh, the agentic mesh, and the zero trust are all combined in order to proceed with faster incident resolution and reduced downtime at the port. So on one side, we have the federated orchestration of the data products that derive from the CM system and UI of the port. We have the drones, we have the security logs, the telemetry logs, and all these data are combined in order and fused into the platform and the agentic system in order to proceed with multimodal anomaly detection, agentic triage and analysis, and self-adaptive recommendations that are being fused and provided to the end user and to the security teams in order to proceed with real-time recovery. All these, of course, are governed via zero trust, that is the vertical spine and the overall compliance mechanism that we incorporated into the functionality of the system. So, what's coming next? What is the present and the future? The concrete integration and efficient integration of these three main pillars. On one side, the data mesh, in order to have the centralized ownership and governance on top of the data, the zero trust mechanism and policy enforcement points in order to ensure that we have continuous verification of the identity of the users, of the identity of the agents, of the evidence and information that is passed across the complete pipeline and across domains and multi-party ecosystems, and finally the agentic mesh that ensures the federated orchestration and the collaboration not only between the agents but also with the agents and the users. And with this, I would like to conclude my presentation. I'm more than happy to discuss with you and answer any of your questions. Thank you so much.
So, thank you, Sandra and George. Other questions?
Thank you very much for a very interesting talk. I'm especially curious to elaboration on the zero trust architectures because we also looked upon this. There are a couple of potential weakened points, and I'm curious to know how you elaborate on them. As for example, that with zero trust architectures, one problem is that edge agents, for example, they sometimes cannot run very rigid and very heavy security checks. And that is a potential leakage. So I'm curious, do you deal with the agents and how you elaborate that? And the second one also related to that, but from compatibility perspective, not compatibility, I'm sorry, compliance perspective, how you also regulated that it's compliant to all the rules. So two weak aspects of zero trust architectures. Would you elaborate, please?
Perfect. Great questions. Thank you so much for them. And they capture two different parts of the zero trust architecture. On one side, how we integrate these agents and how we can once we identify an agent that there is leakage in his code or some adversarial AI has been fused into this specific agent, how we will cut it from the network, how we will leave it on the side. For this, we try a little bit to move also to the deterministic, let's say, world, in order to have some thresholds with regards to the operations of the agents, in order to understand malfunctions, in order to understand if malicious code has been fused into this specific agent, and in order to kind of understand when we need to leave something out of the system, we follow this approach so far. Of course, we have lots of road to follow, and is also a research topic. On the other side, with regards to the compliance, so far we have made a concrete, let's say, desk research with regards to regulations, directives, also with regards to internal policy documents of the critical infrastructures. So all this is used as knowledge and is being fused into vectors, VectorDB, and also knowledge graphs, also in order to ensure semantic orientation of the different compliance mechanisms of the policies, etc. And this is the actual knowledge that we fuse also to the agents in order to leverage and understand the real context, not only from European, let's say, level, international level, but also from local level of the actual pilots. Hope to answer your question. Thanks.
More questions? So you mentioned these 4 pilots. They are all up and running?
Yes, yes. They are all up and running, but of course we have to take into consideration that we are on month 10 of the project. So we are, let's say, we moved right now from the design phase to also fuse the functionality of the system into them. So we want to see the first results in 2-3 months from now.
Okay, and are there any lessons learned you can share from what you did so far?
Co-creation at first. Yeah, co-creation workshops in order to understand exactly what are the commonalities, but also which are the differences between the different critical infrastructures, because The Port of Rotterdam, for example, and the Kijkse-Band, they have totally different operations, totally different legislations and compliance aspects that they need to follow, and totally different functionality of the agents. So definitely, in order to build a consistent system and also to respect the federated orchestration and etc., you need to understand exactly the commonalities and how you can create agents that can be function and utilized in the different environments. So this is the first lesson learned.
Last chance for the audience for more questions. So thanks, Sandra and George, again.
Thank you.
After the lunch break, we will continue at 3.
So, dann geht's heute Abend los. Ich weiß eigentlich, was stand das in der E-Mail? Ich gehe jetzt da runter, wahrscheinlich ist der Frank auch da.